Today's lecture is going to be over dividing decimals. So that's the, let me see which section, 4-5, and we're doing 4-6, both of them. 4-5 is dividing decimals, and when you're dividing decimals, I guess I need some paper around. We're dividing decimals. Okay, you're going to do regular division, like if you have a whole number on the outside, like number 1 says 7 into 27.3. Since there's a whole number out here, you can start dividing right away. You just bring your decimal from your problem, bring it straight up into your answer. Okay? When you divide 7, you cannot divide it into 2, so don't put your number here. 7 into 27 goes how many times?
3. 3 times.
3 times. 3 times 7? 21.
I'm sorry.
Subtract.
6.
Bring your next number down. You don't need to bring the decimal down. You've done all you need to do with your decimal.
So just
7 into 63?
9.
9. 9 times 7 is 63. And now you're done. If there was another number here, you would have added a 0 and brought it down.
But the decimal just goes in the beginning.
This just goes up into the answer, and there's your answer right there. Okay? If you have a problem that shows you like 1.62 over 6, the part that goes under the division sign is your top. And then do it just like we did the problem before. So bring your decimal up into the answer. 6 will not go into 1, so 6 into 16.
2.
2. 2 times 6? 12. Subtract. Bring the 2 down. 6 into 42?
7.
7. And it's over. Don't write it with just the decimal in the front, so go ahead and put 0.27. And when you put zeros in front of decimal, you only need to put 1. I've seen some people put more than 1 0 in front. You only need 1. You don't put 0.27. There's no reason to put more than just 1, okay?
And you don't have to put the 0 at all if there's a whole number there, right?
Right. If it's like, if your answer comes out 1.23, you don't need to put any zeros in front, okay? I've just seen some of the answers and I was like, ooh, I better clear that up. Okay, now if you have a decimal on the outside, we have 20.01 divided by 0.05. Now what you want to do is make a whole number on the outside. So we need to move our decimal to the right 2 times to make it a whole number. If you move it 2 times on the outside, you need to move it 2 times on the inside also. So put your decimal there and bring it up into your answer, and now we're not concerned with the decimals anymore. And now instead of 0.05, we're divided by 5, which is way easier, right? You don't have to see what to multiply 0.05 by.
So can we remove the 2 zeros in front of the 5?
If you want to erase them to make it easier for yourself, you can, yes. You don't have to, but if it will help you, go ahead and erase that. Okay, now you go 5 into 20. And since you can't put it into 2, don't put your 5 here. Put it above the 0. 5 into 20 is 4 times, right? 4 times 5 is 20. Bring your 0 down. Okay, 5 won't go into 0, right? So you have to put a 0 there. How about 5 into 1? You can't put 5 into 1 either, can you? So another 0. Now add a 0 behind the decimal and bring it down. 5 into 10. Now there's something you can actually put it into. 5 into 10 is 2. And now you're done. So your answer's right there. Let's do another one like that. How about number 7? We have 1.5 into 54. Okay, move it one time here, one time here. If you had to move it one time and there's nothing there, you need to add a 0. Now, if this confuses you having this point here, erase that so you don't look at that anymore. Now we're doing 15, okay? 15 is going into 54. It can't go into 5, so it's going into 54. 2 times 15 is 30. 3 times 15 is 45. So we're going to do 3 times 5, 3 can carry. Okay, we got 45. We need to borrow. 14 minus 5, 9. Okay, 15 into 90.
So don't worry about bringing down the 0, right?
Yes, you do bring down a 0.
Okay. I'm blind today.
Yeah. Okay, remember 2 15s is 30. So 3 of those are going to give us 90. So it should be about 3 of that. So 15 times 6 should be 90, right? 6 times 5 is 30. 6, 7, 8, 9. So that came out to 36 point. Okay? If the point is behind the number and there's nothing following it, we don't need to even write the point in our answer. You don't need to write point 0 or point anything. It's just 36.
Oh, so when your decimal's at the complete end, it turns into a whole number.
Right. If it's at the end, it's the same as just a whole number. Okay. There's some of the problems here that says to use the fact that 108 divided by 18 is 6 to work the problems 9 through 12. Okay, so number 9, it says 0.108 divided by 1.8. Okay, so we already know that there's going to be 6 in there because we have 108 divided by 18 out here. Let's just move our decimal to see where our decimal is going to end up, okay? Move our decimal one time here. Okay? 18 will not go into 10, it goes into 108 6 times. It won't go into this. Make sure you put the 0 here. 18 goes into 108 6 times. So if it starts with a decimal, what do we do?
Put a 0 in front of it.
1 0. No more than 1. Just 1 0 in front of the decimal. Okay, so that's what you do. You don't actually have to show multiplication here. So your answers for 10 and 12 will have a 6 in them somewhere. You just have to figure out where the decimal is. Okay, how about, let's do a little bit harder. Let's do 0.034 divided into 342.81. So we need to move it on the outside 3 times. 1, 2, 3. So we need 3 times in here. 1, 2, 3. Okay, our decimal is going to be here. 34 will go into 34 one time. So that's the easy part, I guess. Okay, we'll bring the 2 down. 34 into 2. 0 times. Bring the 8 down. 34 into 28. Won't go, will it? 28 is smaller than 34. So now we need to bring the 1 down. Now it should go. Let's see, 34 times 9 is 36, 27, 30, too big. 8 times 4 is 32. 24, 27. So 8 is right. 272. You need to subtract, so you need to show your borrowing. 11 minus 2 is 9, and that's zeros. You don't need to bring your zeros down, except for the one that follows it right there. You don't need to put the zeros in front here though. 34 into 90, that's not going to be very big like that. Let's try 2 is 68, times 3 will be too big, right? 9, 10. So we want to do times 2 is 68. We have to borrow 22. Let me bring it up so we can see a little better here. Okay, we need to add some zeros. On this problem, this number 19, it said to round to the nearest thousandth. If you're rounding to the nearest thousandth, the thousandth, how many places after the decimal?
3.
The thousandth is 3 places after the decimal. To round to the thousandth, you're going to need to go 4 places because you'll need to look at the next number to see whether to round up, right? So we need to go 4 places unless it stops. So this is only the first place after the decimal. We're barely going to have room here. Okay, 220, we better try some more numbers here.
Let's try 6 maybe.
Okay.
I was thinking 6.
15. Let's try that 6. 34 times 6. 24, 18, 19, 20. Yeah, it won't go another time, will it? So we'll put a 6 there. 204. Show your borrowing. 10 minus 4 is 6. 1 minus 0 is 1. Another 0, right, bring it down. Okay, let's try the 5 to see, just so we'll know what it is. 5 times 4 is 20. 15, 16, 17, that's too big. So we'll do 4, 136. 4 is 136. Show your borrowing. 10 minus 6 is 4, 5 minus 3 is 2. 1 more 0, 240. We haven't done the 7. Let's do the 7. We have all of them up there now. 7 times 4 is 28. 1, 23, 238. So that's the one we needed. 7 is 238. So that one's just 2. Bring the next 0 down. It won't go into 20, will it? It won't go into 20. You would have added a 0, but we don't have to go that far. We just need to go to the 4th number. We're rounding to the thousandth. So we're looking at that 0, and we know we don't need to round up. So your answer is 10082.647. And don't put the 0. You only go 3 places.
So you don't go all the way till it adds up? I mean, till it...
It said to round to the thousandth. So you
Oh,
only have
okay.
to go 4 places to do that, to round it. Okay? And since this is over 4 numbers in the front, you need a comma there. If it was 4 numbers, you could have one or not. It would be a choice. Okay? Now let's do where you're dividing by 10. Let's take the number 2.82 divided by 10. You're going to still have these same numbers when you divide by 10, 100,000, or 0.1. Okay? You're going to still have the 282 in your answer. Let's divide that by 10 and see what you get. 10 into 28 is 2. 10 into 82 is 8. 10 into 20 is 2. Where's the decimal going to be?
it's gonna, there was no 2, there was no decimal in the 10, so that means the decimal's gonna stay the same place, right?
Straight up, right?
So you just moved it over one place?
Not
Yeah.
the whole.
From 282 or 2.82, when you divide it by 10, you just move it one place
Right, over.
to the left.
Gotcha.
If you're multiplying by 10, you would be moving it to the right, making it bigger. When you divide, you're making it smaller. If you divided by 100, the same number, if you divided it by 100, you would move it 2 places.
Add a
Count
zero
the
for
zeros.
the
Yeah. There's 2 zeros here, you're gonna move it 2 times. 1, 2. So divided by 100 would be 0.0282. We moved it 2 times.
So to the right, it would make it smaller?
Dividing it makes it
Right.
smaller. Okay? What if you multiplied it by 10? 2.82 times 10,
It would be 28.2.
28.2. 2.82 times 100,
282.
282. So you move it the number of zeros you have. Okay, how about if we divide by 0.1? 2.82, we're dividing it by 0.1. Let's do that. 2.82 divided by 0.1. Move your decimal. Move your decimal so it goes right there. Okay? 1 into 2, 2. 1 into 8, 8. 1 into 2 is 2. So we moved it the other way, didn't we? You're dividing by 1/10. This is the same as multiplying it by 10. You move it 1 time. How about if you divided it by 0.01? What do you think would happen? That means that you had 0.01 here, you had to move it 2 times here. That means it's going to move it 2 times here. It's going to move it 2 times. This is the same as multiplying it by 100. Okay? You can actually do the work if you want for 1 or 2 of them, but when you see a pattern, you don't just keep having to do the work over and over. So if you had 0.01 into 2.82, you went 1, 2, 1, 2. So your answer is 282. You moved it 2 times, right?
And so on as the zeros.
Yeah. You would count how many of these to see how far you moved it. This, you moved it 1 time. If it's behind the decimal, you count this. If it's times 10 or 100, or divided by 10 or 100, you count the zeros. But on these, you count how many numbers are behind the decimal. And if you ever forget, just do the work. Divide it or multiply it. It's not that hard to multiply or divide by 10 or 0.1. Okay? So don't get it wrong just because you forgot. Okay, what if you have to estimate?
In
Okay.
dividing?
Okay, on page 306, it wants you to estimate some division. It gives you a problem like number 23 says 37.8 divided by 8. And it says the answer is 47.25. And you should estimate it to see if that's reasonable. Okay, so this would be about 38. That doesn't divide evenly by 8, does it? Let's kind of round it where it comes out even. Let's maybe say this is about 40. That divides by 8 evenly. What is 40 divided by 8? 40 divided by 8 is 5. This is our estimate. Is 5 anywhere close to 47?
No.
No. The answer is probably 4.725, right? If those are the actual numbers in the answer, it's probably 4.725, because that's closer to 5.
But the decimal wouldn't move over here, so.
So if you actually do you don't have to do the work, okay? It doesn't say, oh yeah, it does. If it's not reasonable, I'm sorry. Yes, you do have to do the work. If it says, if it's not reasonable, find the right answer. So this one's not reasonable, so okay, find the right answer. We're probably gonna use those numbers. 8 into 37, 4 times 8 is 32. Bring 5 down, 58, 8 into 58. 7 times 8 is 56. Bring the 0 down, 8 into 20 is 2. 2 times 8 is 16. Bring a 0 down, 8 into 40 is 5. So see, your actual answer is 4.75, which is what we guessed it would be anyway.
4.725.
4.725, yeah. I've been lazy. If you watched that screencast from the other day, there was a couple of numbers I turned around and I said the wrong numbers a couple times, but all the work was right, so I put a little note up on the screencast to just ignore the numbers that I said wrong. But if you know, I'm not going to go back and redo it because I messed up. I mess up in every class, so I make my screencast messed up too. Okay, so that's the estimates. If it's right, you don't have to get the right answer though, okay? It said if the exact answer is not reasonable, you have to find it. So hopefully the ones you do, there's some reasonable ones there. Right? Okay. Word problems. I think you could find the price of one notepad and like 32. 4 notepads for $1.69. How much is one notepad? What would you divide? Would you divide 4 divided by this, or this divided by 4? This is the price for 4 notepads. Okay, if you want the price for one notepad, you're going to do that divided by that. You do 1.69 divided by 4. Does that make sense? So you'll have the price per one notepad.
So the $1.69 is not for all 4 notepads?
Yes, it is the price for all 4 of them.
So you would,
So you need to divide that by 4 to find the price for one.
oh, okay.
So you
Would you
divide
be
by 4.
48
So 4,
cents?
and then 2, because the 9 comes down, 2 times 4 is 8. And then 4 into 10 is 2. And 4 into 20 is 5. Okay, did it say to round it? In the problem above that, in the description for these word problems, it says round money answers to the nearest cent. Okay, I've seen people have a little bit of trouble rounding to the cent. Okay, you don't round to the one, like the ones place either. Where is the cent?
It's the second one.
The
Number
4?
9.
The 2?
Yes.
Yeah, this is the cent. This is how many dimes, this is how many pennies. So this would be the cent that you're rounding to. So look at the 2 that follows it, and you're not going to round up because of a 2. So it'd be 0.42 with the dollar sign. Or if you want to write it in cents, you would put 42 cents. But don't put 0.42 followed by a cent. If you're doing it like this,
That's
the
dollars.
dollars. This is the cent notation. So you could write it either way.
Well,
Okay.
if the one's a dime and the other one's a penny, what's the third one? Is
It's,
there a table for the cents?
it's a tenth of a penny.
Oh. And the other one would be
That'd be a
hundredth
tenth of a penny, a hundredth of, yeah. Yeah.
Is there a table for the cents or?
No, it's just common sense. It's just like, this is how, 69 cents. This is your cents. The two numbers here is how many cents there are.
And if it's 169, then the decimal goes after the 9?
If it's $169 what? Dollars?
Like in money?
If it's $169,
It's just like that.
it'd be like that, there would be no cents right there. This is your pennies
just
and
like
this
it.
is your dimes. This would be your $1 bills, your $10 bills, your $100 bills, ones, tens, hundreds. This is the tenth of a dollar, which is a dime. This is a hundredth of a dollar, which is a cent. Okay, so like 34, I'm not gonna do 34. That's one you can do. If it says how much you're gonna pay per something, like number 33 says how much does she pay each month?
Divide.
Per month. You're gonna be dividing by how many months? Okay, so you're gonna have the price they paid, and it said there was 21 equal monthly payments to pay off her credit card. So there was 21 payments, and there was 1408.68 that had to be paid. So there's 21 monthly payments. So for one monthly payment, you're gonna have to divide that by 21. So when you have a price and how many of something, it usually wants the price for one. If it says what is your price for one of them, you're going to do the price divided by how many. Okay? So most of the word problems would probably be a price by how many, divided by how many of it, of whatever it is.
Like that's 21 months, so it's divided by 21 months.
Yeah, that will be divided by 21. But I'm not going to do it, you know. That's just telling you how to do them. Okay, on page 307, you have some word problems here. I've got some parts here kind of highlighted to make sure that you understand the average length of all the long jumps listed in the table. You know how to do average length? Average, do you know how to do average your grades?
That would be an estimate, wouldn't it?
No? An
All
average
up
isn't
and
exact.
divided by how many numbers
Yeah.
there?
If you had a list of your grades, you would add them up and divide by how many grades, right? That's how you do all your averages. You always add them up, divide by how many. You add, okay, so if you're doing the average length of all the long jumps, you actually need to do all of these lengths. You need to add those up, okay, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 jumps there. So add them up, it's probably going to be 70 something, because it looks like there's 10 of them that are over 7. So it's 7, it'll be 70 point something. What will you divide by to get the average?
The number of people.
How many did I tell you there were? 10. So you're going to add all these up and divide by 10 to get number 42. Okay, 44, if the first place athlete made 5 jumps of the same length, what would the total distance jumped? What would the total distance be for a jump? They actually are in order. See, this is the smallest one, the shortest length, little longer, so the first place person is right there. If that first place person made 5 jumps of the same length, so if he made that same thing 5 times, what would the total be? You're either going to multiply it by 5 or add it 5 times, right? That's the total distance that he would have jumped. That distance times 5 or that distance added 5 times. Come out to the same thing. And 46 says how much less was the last place jump than the next to last? Which one is the last place?
707.
7.07. The next to last?
709.
7.09. So just have to subtract them to see how much less it was.
Just 0.02.
Point, yeah, 0.02. Okay? Order of operations are the same as we've been doing with regular numbers. You're just doing it with decimals now. We still use, please excuse my dear Aunt Sally. Right? Parentheses, exponents, multiplying and dividing, left to right, adding and subtracting, left to right. You need to get these down pat because you're going to keep doing them and they're going to keep messing you up if you don't get these down pat. Right? Oh, she's not listening. Yeah. Yes. I thought, because she's in another class and she knows that this stuff will mess you up over and over and over if you don't get it. Okay, so let's do one that has a little mixture of about everything. Number 53. 33 minus 3.2, parentheses 0.68 plus 9.
43
53.
or 53?
Minus 1.3 squared. What's to say to do first?
Parentheses.
Parentheses, so let's do that first. 9 plus 0.68,
77.
we're just adding those, right? Okay, what did it say to do next? Exponents, so we're going to do this squared, so we're going to do it times itself, right? We're going to do that next.
Right.
Okay, what's 1.3 times 1.3? One, two, so we go back 1, 2. So it's 1.69, right? After exponents, we're going to be doing our multiplying and dividing. So that's actually what we're going to be doing next right there. So we'll go ahead and do it on this line. 3.2 times 9.68. I'll put the long one on top so we don't have to multiply as many times here. 2 times 8, 16. 12 and 1 is 13. 18 and 1 is 19. 0, then we do 3 times 8, 24. 3 times 6, 18, 19, 20. 18, no, 27, 28, 29. That's why you need to know your multiplications real good. Doing all this stuff, you miss a number, you're going to mess the whole problem up. 91 is 10, 3. Where's the decimal go?
3 places over.
1, 2, 3, 1, 2, 3. So this, we still have the minus here. We have 30.976. Okay? So now do 33 minus 30.976. 33 minus 30.976. Do we just bring the 976 down? No, we need something to subtract it from. Okay? Make sure you borrow. Make it 9, make that 9, make that 2. We don't need to borrow any farther. 10 minus 6 is 4. 9 minus 7 is 2. 9 minus 9 is 0. 2 minus 0 is 2. 3 minus 3 is okay. We don't need to go any farther. 2, this part right here is 2.024. Now we got to subtract 1.69 from that. Well, let's just go ahead and do it right here. 1.69.
Add a 0.
4 minus 0, 4.
Borrow.
Up, borrow. we can't borrow from 0, so we had to borrow to make it 10. But now we can borrow, because it's 10, we gotta make it a 9, right? 12 minus 9 is 3. 9 minus 6 is 3. 1 minus 1 is 0. So that right there is 0.334. So these problems will take you a little while. But you're going to have a lot of work showing, and don't erase it. Go ahead and leave it showing somewhere, okay? Because you need to do all kinds of work with it. Okay, I think that's all that you need to be told. You can probably figure out the rest. If you can't, you can give somebody a call, give me a call, or a fellow classmate a call. 4.6, you're writing fractions as a decimal. Okay, the fraction 1/2. You already know what that is as a decimal, don't you? 0.5. What would you do with these numbers to get a 0.5?
That's gonna be 5/10, right?
Divide.
Divide top divided by the bottom, right? Top divided by the bottom means you need to add a decimal. 2 won't go into 1, so put the 0, 2 into 10 is 5. So if you ever forget which number goes inside, do your 1/2 and it'll remind you. The top number has to go inside to get 0.5. Okay? What about 3/4? Which one goes under here? The 3. Divided by 4. Won't go into 3, 4 into 30. How many?
Or 7.
7. 7 times 4? Okay. 20 is 5. Okay, so it's 0.75. Does this look like money to you? A $1/2, 50 cents? 3/4, 3/4 is 75 cents? Wonder what 1/4 is going to be? 0.25. You can do the math and then you'll get it. 0.25. So those are the easy ones. Those should be some that you should know pretty much off the top of your head. Just look at it as 3/4. Oh, that's 75 cents. 1/4. Oh, 25 cents.
Okay, yeah.
Okay? Dividing by 8's not usually fun. Okay? Dividing by 8, you usually have 3 numbers instead of 2. 1 divided by 8. Okay, 8 into 10. 1 time. 8 into 20. 8 into 40. 5. Okay? All of the ones that divide by 8, well, of course, except 4/8 will be half and like that. But most of the 8s will have 3 numbers. If you do like 5/8, it's going to have 3 numbers. 6/8 will be the same as 3/4, of course. A lot of the 8s will have 3 numbers. If you decide to be a machinist, you'll have these things memorized because they work with decimals and fractions. Instead of fractions, they always use decimals. And like if they're going to do lathe work and cut something down, they do it to the nearest thousandth. So they would do it to where it was to the nearest thousandth of what it needed to be when they're cutting that metal, shaving down. Okay, what if it has a number in front of it? What if we had 1 and 1/2?
Yes, it is a mixed number, right?
It is a mixed number.
I mean,
The decimal. Okay, so we know 1/2 is 0.5, right? So what's going to go in front? That'll be 1.5. What is like 2 3/4? 2 goes in front of the decimal. What's 3/4?
75.
3/4 is 75. Okay? So some of those are easy. The 1/3 and 2/3, those always repeat, okay? Right. 1/3 goes 3 times, and then it goes 3 times again, so it keeps repeating. 1/3 is 0.3 repeating. So what is 2/3? It's double. Yeah, the bad word. I never write 3 of them. I'll put 4 and I'll put 2, but I'll never put 3. Yeah.
Yeah.
Yeah. Okay. And the 9s, they do that too. It's weird. How about 8/9? Let's do 8/9. What is that? 8 divided by 9. 8 times? 8 times 9 is 72. Oh, look what it did. It'll be the same thing again, isn't it? I think all the 9s end up being the top number repeated. Shall we try that on another number? 2 9s? 2 divided by 9. 2 times. So it's the top number repeated, isn't it? So if the 9s is on bottom, it's that number with the repeated sign over it. Okay.
And we're not gonna go any further because that 9 is in the 10th spot, right? Is that what I'm thinking? All right, is that
Okay, 2
correct?
into 9, 18. Then you're going to have 2 again, and again, and again, and again.
But what I'm asking is that 9 represents the 10th spot, right?
Which 9?
On the
Outside
2
here?
9s right here.
2 9s?
That would represent the 10th spot, wouldn't it?
Whole number.
This 9 right here?
Uh-huh. Wouldn't that represent the 10th spot?
No, I don't think so.
Just the one,
Because it's not behind a decimal.
Oh, okay.
otherwise.
I think I wasn't understanding the question. I'm glad somebody understood the question. I didn't understand for sure the question.
So that would be considered a whole number?
No, that's not a whole number. This is
Whole part.
called a repeating decimal.
No, I'm talking about the 9.
Talking about
Yes, the 9 is a whole number. You don't have to move your decimal. And these are repeating decimals. If 2 numbers repeat, then you have to put the line over both of them. And if I knew one right off the bat, I would tell you, I would show you one. I can't think of one right now. Okay, what if we're given a decimal and we want to go back to a fraction? What if we were given the 0.5 and we wanted to get to the 1/2? If we didn't know it in our head, how would we find it?
Would you divide it opposite?
That's 5 what? Say what this is.
5/10.
5/10? It's 5/10.
Okay. Reduced down to 1/2.
Then just reduce it. Okay? So how about 0.24?
24 hundredths
24 hundredths. What can we divide by?
divide by 2, which is the easy.
Let's try 4.
6 and 25.
Okay. Those won't divide, will they?
No.
2 and 3 and 5 and 5. So that's as far as you can go on that. How about one with 3 numbers? 625 1,000ths.
Divided by 25.
We'll divide by 25, yeah. So this would be about, what, 25?
25.
Is it?
I don't know, 4 and 100 is 24. 24,
25 times on top. 25 into 100 is 4,
500.
so it's 40. See, into 100 is 4 times, and then just add the 0.
Okay.
And we can still divide, so we must not have divided by the biggest one yet.
Not these.
5, divide by 5, 5 eighths. Remember I told you the eighths always have 3 numbers? That one's got 3 numbers,
Spears.
25 meters.
okay? How about... It'd be 111 over 1,000. Can that be reduced?
No.
I don't think so.
No, that was prime.
That's it.
Yeah.
Okay? How about if you're going to order from largest to smallest, if you have a bunch of decimals? Let me give you some decimals here.
Did you say going larger to smaller? Is that what you said? Going
Let's,
from
well, let's go from the smallest to the largest. How's that? Let's go small to large.
0.5399.
Okay, they all have the same tenth, right? This has the smallest in the hundred, so that's your smallest. Okay, out of these two, they both have the same number here. This has a 5. Since this doesn't have one, it'd be like it having a 0 there, right? So this
that
must
one's
be
gonna be
larger
your
than
little one.
this. So this would be the next smallest one. And then the next one. Okay, so y'all shouldn't have trouble ordering them. What if they're mixed up? Decimals and fractions mixed up. You need to learn those because they're going to be on the test, so let's do some of them. Okay, let's do one. Let's do one like this. 3/8, 2/5, 0.37, and 0.4001. Okay, all these numbers can be turned into fractions. Oh, that would be hard to compare, wouldn't it? Why don't we turn them all into decimals? Wouldn't that make it easier?
Yeah.
Yeah, so let's do these two numbers, turning them into decimals. 3/8. We know it's going to have 3 numbers, don't we? 8 into 30? 3?
3.
It's 24. 8 into 60? 7 times 8 is 56. And 5. Okay, so this one is 0.375. 2/5. We could divide it, or we could say, how many tenths would that be? 4 tenths? 4 tenths is 0.4, isn't it? So you could either do 2 divided by 5 and get the 4, or you could say it's 4 tenths, so I do 4. Whichever way is easier for you, whichever way is easier to understand. Okay, now small to large. We're not going to do the 4s yet. The 3's here, the 3 is the same. The 7 is the same. There's a 5, this would be like a 0, right? So this is the smallest one. 0.37, that's our smallest one. This is the next one, but don't write it like this. The problem had 3/8. So you write 3/8 next. Okay, out of these two, which one is next? 0.4, which was 2/5 in the problem, right? And then the last one, and this is the way it was in the problem, 4001. So that's small to large. And of course, large to small, you just go backwards, right? You don't need to do one backwards. Okay, I think that's all that I need to go over with you. Is there any questions?
I grade it.
Sure.
Who's gonna grade on it?
Okay, no questions? Oh, okay.